Hello. This time I'm going to explain the homework section 3.7 in the calculus textbook. This is about implicit differentiations. There are 20 questions on the homework, and most of them is basically same, but computationally it takes quite takes time. So I'm going to cover most of them, but not all. So number one, find y dash of 2x squared y plus 3x y squared is equal to 5. So let's differentiate both sides of the expression first. So you want to differentiate both sides with respect to x. Okay. Now right side is easy. Derivative of 5 is equal to 0. Left side, you have addition here. So you just need to take a derivative of this part and this part. However, each part is actually a product, so you have to use a product rule. Now this part, let's do this part first. So derivative of the left and the right. So 左微分 4x times 右 y plus 左 times the derivative of y, which is y dash. Do the same thing for this one. Derivative of 3x is 3. So 左微分かける右 plus 3x times the derivative of y squared is 2y times y dash by the chain rule. Okay, so now I just to simplify this expression for y dash. So this looks complicated, but it's just a linear equation in terms of y dash. So let's combine these two terms together and bring these to the right-hand side. So you're gonna get 2x squared plus 6xy times y dash is equal to negative 4xy minus 3y squared. So finally, divide both sides of the equation by this. So you're gonna get 2x squared plus 6xy on the denominator. On the numerator, it's minus 4xy minus 3y squared. Okay, so that's gonna be our final answer. Okay, number 2. It's gonna be the same kind of question. X to the power of 5 plus y to the power of 5 is equal to 20xy. Right-hand side is not equal to 0, but we still can differentiate both sides by x. Okay. Now left side is the derivative of x to the fifth. It's going to be 5x to the fourth. And the derivative of y is 5y to the fourth times y dash. Okay. Whenever you take a derivative of y, you're going to get the y dash by the chain rule. Right side is, again, you have the same thing. You have a product of two things. So you have to use the product rule. 20x, derivative of 20x is 20 times y, 左微分右 plus 左 times the derivative of y, which is y dash. Again, this is a linear equation in terms of y dash. So combine these two yellow terms in the left side of the equation and combine these green terms on the right. So you're gonna get 5y fourth minus 20x parentheses y dash is equal to 20y minus 5x to the fourth. Now divide both sides by this. We're gonna get 20y minus 5x to the fourth over 5y fourth minus 20x. All the terms are multiple of 5, so you can factor 5 out on the numerator. And you can product out 5 on the denominator too. Oops, it's 4 here. And you can reduce the fraction. Okay. Now, next one is basically same question, same idea. Well, nothing new really. So problem number 3. X to the fourth minus 16xy. Be careful, this is a product. Plus y to the fourth is equal to 1. Differentiate both sides with respect to x. Don't forget that one derivative of 1 is 0. And you do this one, it becomes 4x cubed minus 16y minus 16xy dash. So this part is kind of complicated. Other part should be not so hard. 4y cubed times y dash. Here's one recommendation. When you are dealing with this one, especially this negative is kind of tricky. Factor out negative 16 and just focus on derivative of this part. Okay, so it's going to be negative 16 times 左微分右 plus 左右微分. And after that, you expand it to get this. This might be safer to do with this computation. Now, again, this is a linear equation with respect to, in terms of y dash. So combine these yellow part on the left side and the remaining part on the right side. So it's going to be 4y cubed minus 16x times y dash is equal to 16y minus 4x cubed. Now divide both sides of the equation and simplified by divided by 4 on top and bottom. You're going to get 4y minus x cubed over y cubed minus 4x. Okay. Next one, a bit complicated one. Now you might have to use quotient rule on the right side of the expression. So 5y squared is equal to 3x minus 2 over 3x plus 2. So idea is the same. You can just differentiate both sides of the equation by x. So you're gonna get, so differentiate, you're gonna get 10y times y dash. And that is equal to, you have to use the product quotient rule, bottom square, 上微分下 minus 上下微分. This is a bit complicated, but this is just a linear equation and expand and combine like terms. So you're going to get 9x minus 9x gone, 6 minus minus 6, which is 12. So it's going to be 12 over 3x plus 2 square and 10y, y dash. Divide both sides by 10y to obtain y dash. So it's going to be 12 over 10y times 3x plus 2 square. Okay, and after this, you can reduce top and bottom by 2 to get 6 over 5y, 3x plus 2 square. Okay, now we're going to have some trig functions. So it's going to be a good review for differentiation with a trig function. So number 5, x is equal to secant of y. Remember, secant, derivative of the secant is secant tangent. Okay, so derivative, differentiate both sides by x. Left side become 1, right side become secant y, tangent y. And don't forget, by chain rule, you're gonna have a y dash at the end. So you're gonna get 1 over secant tangent is equal to y dash. So that's the answer. But remember that the secant is just a reciprocal of cosine. So you can rewrite it as cosine y over tangent y. If you do not like fractional expression, you can also change tangent to cotangent. So that's what I got on the left. Okay, again, now you have a tangent. Remember, the derivative of the tangent is secant square. So that's the idea. So if you have tangent u, it's gonna be secant square of u times u dash. Now let's take a look. Number 6. So x minus tangent xy is equal to 6. Now differentiate both sides with respect to x. You're gonna get 1 minus derivative of tan, which is secant square of xy. But don't forget, you have to multiply the derivative of the inside, which is product of x and y. So it's gonna be 左微分右 plus 左右微分 as usual. And don't forget to change 6 into 0 because you differentiate it. Okay, so it looks complicated, but it's just a linear expression. So you solve for y dash. Oh, please note, xy is inside the secant function, but this parenthesis, this one is not. So after expand it, you want to get like basically y times secant square of this angle minus xy dash times secant square of xy, and that's equal to 0. And we are solving for this. So let's move this expression to the other side of the expression. And so you get 1 minus y secant square xy is equal to x times y dash times secant square xy. And divide both sides by this stuff. You're gonna get y dash is equal to x secant square xy and 1 minus y secant square xy. Okay. So it looks like, well, my answer looks different, but what I did is after doing this, I just multiply both sides by cosine square. Okay, so actually this is how I did. So from here, actually I did something different, but basically my answer is you can get it by multiply top and bottom by cosine square of xy. Then cosine times secant canceling each other because they are reciprocals. And when you expand this one, this part will be also disappeared, and you want to get cosine square of xy minus y over x. Okay. Okay, now you're gonna get the exponential function, but you also have a sine function. Remember, the derivative of e to the x is e to the x. So derivative of e to the u is e to the u times u dash by the chain rule. Also, the derivative of sine is cosine. That's something you will need to use. Okay, now differentiate again. You want to get e to the 2x times derivative of this part, which is 2. Sine of something, when you differentiate, you're going to get cosine of the same angle times derivative of the inside, which is 1 plus 6y dash. So I'm going to solve for y dash. I can expand it, but let's just divide everything by cosine. So you want to get 2e to the power of 2x divided by cosine of x plus 6y. Then it's going to be 1 plus 6y dash. Now subtract 1 and divide it by 6, you're going to get y dash. So 2e squared over cosine x plus 6y minus 1 divided by 6. And that's going to be the answer. Now, I just rewrite 1 over cosine into secant, so it looks nicer. because it avoids fraction inside a fraction. Yeah, but if you want to keep cosine, then multiply top and bottom by cosine, then it looks a bit better. So you can rewrite it into this form. That's okay. Okay, so that's probably a better answer. But I just rewrite 1 over cosine into secant. That's what I did, and that's the answer written here. Okay, well, now you need to find the second order derivative, but the general procedure is the same. You just have to differentiate twice. Okay, number 8. So you got the 4x squared plus 3y squared is equal to 4. Now let's differentiate both sides of the expression with respect to x. As usual, you're gonna get 8x plus 6y times y dash by the chain rule, and the derivative of 4 is equal to 0. So y dash is equal to negative 8x over 6y, which is negative 4x over 3y. So that's the first part. Now I need to find the y dash dash. So again, I have to differentiate this expression. Okay, so I'm gonna differentiate both sides with respect to x. Derivative of y dash is y dash dash. Derivative of this part, you have to use a quotient rule. So the denominator square, 上微分下 minus 上下微分. Okay. So this, you can divide top and bottom by 3 to simplify a fraction a little bit. So it's going to be 3y squared minus 4y plus 4xy dash. So that's going to be y dash dash. Now, you do not want to have a y dash in your final answer. You want to use x and y. Okay, although the problem doesn't say find the answer in terms of x and y, you want to avoid using y dash in your solution. So using the first result, substitute this into here, you want to get negative 4y plus 4x times negative 4y over 3y over 3y squared. I'm not sure whether the Pearson will accept this answer, but I'm not going to accept this as a final answer. So you don't like to have a fraction inside another fraction. So let's multiply numerator and the denominator by 3y to make it look nicer. So the denominator becomes 9y cubed, and the numerator is after you do expanding. So you expand it to 2 terms here and here. You want to get negative 12y squared minus 4 times 4, which is 16x squared. Okay. Okay, this is just a review question. Yeah, so it's nothing related to section 3.7, but let's do this one. Of course, this is important. So the formula is already given here. So this is just a review question, number 9. So you need to find the limit of this expression, 1 minus cosine over sine of 16 theta. Well, 取りま代入 and you want to get sine of 0, which is 0, and 1 minus cosine of 0, which is 1 minus 1. So this is 0 over 0 type question. So you want to use the formula to deal with a 0 over 0 type expression with the trigonometric x functions. Here are the key things here. When you see 1 minus cosine, often you want to multiply it by its conjugate. which is 1 plus cosine. So let's multiply top and bottom by 1 plus cosine to create sine. Okay, now the bottom, you can leave it as a factored form like this. But the top, you want to expand this one. So you want to get 1 minus cosine square, which is same thing as sine square. Okay, now you see that the 0 over 0 here. But to use a formula, I might want to rewrite it like this. So numerator have double zeros, sine 0, and sine theta and sine theta. So denominator have sine 16 theta. So that's here. So you got something like this. Let's multiply top and bottom by theta. So you can use a formula to deal with this part. And also you can use a formula for this part. Let's multiply top and bottom by 16. So this gonna be 1 by the formula. Well, if theta is going to, if this theta go to 0, this is 1, then 16 theta is also equal to 0. So you can use the same formula, although its numerator and denominator switched. Okay, yeah. When you can use this formula, you also can use its reciprocal going to 1 as theta goes to 0. So this will goes to 1, this will goes to 1. This one gonna become 0 over 16. And this is just 1 here, so it's gonna be 1 over 2. So 0 times 1 times 1 times 1/2. So it's all converging to some finite number. The product will be 0. Okay, so the answer is 0. Okay, this is very terrible. Oh, now you have a square root. Yeah, so let's go back to, oops. Let's go back to implicit differentiation question with something terrible here. So now you have a square root of y here. Let's differentiate both sides with respect to x once again. Okay, so differentiate both sides. The right side is easy, 1 minus 3 times y dash. And the left side, remember, square root of x, derivative of square root of x, just memorize this. Just memorize this. And if you have a u here, you wanna have multiplied by u dash, so it's gonna be like this. So this will be 4 times 2 square root of y and y dash here, okay? So it's gonna be 2y dash over square root of y is equal to 1 minus 3y dash. Let's multiply both sides by square root of y because I don't like fractions. So it's going to be 2 square root of y, y dash is equal to square root of y minus 3 square root of y, y dash. So this is a linear expression for y dash. So let's combine these two terms on the left side and leave this as at the right side. So you want to get 2 plus 3 square root of y times y dash is equal to square root of y. So y dash will be 3 square root of y plus 2 and square root of y on the top. Okay, so that's y dash. Well, this is only first half of this question. Now we need to find y dash dash. How do we find y dash dash? Well, we have to differentiate this one. Okay, we have to differentiate this one. Well, sounds terrible. Yeah, sounds not really fun, but let's do this. So y dash dash will be derivative of this. So 3 square root of y plus 2, you have to use the quotient rule, denominator square. 上微分 2 square root of y, y dash by the formula. 上微分下 minus 上下微分. Now 下微分 is 3 times square root of y's derivative, which is this, and the derivative of 2 is 0. So it's gonna be like this. Okay, Now, let's multiply top and bottom by 2 square root of y to kind of simplify this expression. So you want to get y dash 3 square root of y plus 2 minus, after you multiply this part, you want to get 3 square root of y dash over 2 square root of y, 3 square root of y plus 2 square. Now expand this one, you can kind of crossing out this part and this part is actually the same term and they canceling each other. So you obtain 2y dash over 2 square root of y, 3 square root of y plus 2 square. You can cross out this 2 as well. Is it the final answer? Maybe not, because you still have y dash in our expression. So let's use this one to rewrite this one. So it's going to be square root of y over 3 square root of y plus 2 on the numerator, and the denominator is this. Okay, after you reduce this fraction, you're actually getting 1 over 3 square root of y plus 2 cube. Okay. Quite a long computation. Yeah. Is it okay? Okay, so let's move on to next question. Okay, again, now you need to find the second order derivative and you need to find the exact value at -2, 4. So this question have one extra step, which is after you find y dash dash, you plug in the value. X is -2, y is 4. But this expression is much nicer than the previous question, so it shouldn't take much time. Let's differentiate first. You want to get 3x squared plus 3y squared times y dash by the chain rule is equal to 0. Differentiation of 56 is 0. So y dash is equal to minus x squared over y squared. So that's one part. Good. Now let's find y dash dash. Now you want to use the quotient rule. Denominator square. 上微分下マイナス上下微分 which is 2y y dash. So it's going to be minus 2x y square plus 2x square y dash over y to the power of 4th. At this point, you might want to plug in. Well, but you might want to say, oh, shall I rewrite this? Well, certainly. So we can leave it as it is, but let's plug in here to get -2xy squared plus 2x squared y minus x squared over y squared over y to the 4th, which is minus 2xy squared minus 2x4 over y to the 4th, which is multiply top and bottom by y. It's going to be y to the 5th minus 2x y cubed minus 2x to the 4th. Okay, we finally simplified y dash dash into this form. Now let's evaluate y dash dash at -2, 4. So I'm going to plug in -2 for x, which is 4, and the 4 cubed for y, it's 4. So it's going to be -2 to the 32 over 4 to the power of 5. You can factor out 4 square. So it's going to be 4 square minus 2 over 4 to the 5th. Reduce 16, you're going to get 64 16 minus 2, which is 7 over 32. So the answer is 7 over 32. Well, here's some suggestion. The program doesn't ask for y dash dash in simplest form. Yeah, it doesn't ask for this expression. We just needed to find y dash dash at this point. So in that case, you probably didn't have to simplify the expression. Maybe from here you could stop, or maybe here you could stop. And what you do, just plug in -2 and 4 here. Okay. Well, how about this? Well, we don't know what this is, but you know that y dash dash at -2, 4 as well. So you can find y dash dash at -2, 4 from here. So at -2, 4, y dash dash is going to be -4 over 16, which is -1 over 4. And you can use this value to plug in here. Okay, then what we're going to get? So it's going to be 4 times 4 times 4, which is 64, plus, will actually become minus 2 times 2 square, 8, 4 over 4, minus 8. So it's going to be minus 8 over 4 to the power of 4th. Then you can divide both sides by 4. You're going to get this, and you're going to get the same answer. So you really do not need to simplify y dash dash into this form. You can plug in this one anytime after you completed the differentiation. Yeah. This is already, this one, the derivative is finished, completed. From here to here is just simplifying the expression. So it doesn't really change the value. So unless you really have to simplify it, like in the previous question, just plug in anytime you want to. Okay, now I will show you how to do the simplified way for problem number 12. So we need to find the slope of the curve at a given point. So what is the curve is? I don't know. 4y to the 4th plus 9x cubed is equal to 5y plus 8x. And we need to find y dash at 1, 1. That's what we want to find. Okay, remember, the slope of the curve is same thing as slope of the tangent line, and which is same thing as a derivative at the given point. So first of all, differentiate both sides of the equation. You want to get 16y cubed times y dash by the chain rule plus 27x squared times 1 is equal to 5y dash plus 8. And at this point, I'm going to plug in 1, 1. Okay, so at 1, 1, it's nice value to plug in. So it's going to be 1, this is 1, and this is 1. Y dash, you don't know. So it's going to be 16 y dash plus 27 times 1 is equal to 5y dash plus 88. So then you can combine like terms, and you're going to get the answer. Y dash is equal to negative 19 over 11. Okay. Of course, if you really want to find y dash, if you really want to find the y dash, then like in the previous programs, you solve for y dash. So bring these yellow terms to the left side and bring these green terms to the right side, then divide. You should get something like this. 8 minus 27x squared over 16y cubed plus minus 5. And after that, you want to plug in. You still got the same answer. Okay. Okay, now this is asking for a bit more. After you find the equation, slope of the tangent line, you need to find the equation of the line actually. So one more step, or well, 2 more steps to do. Okay, so number 13 is x squared plus xy minus y squared. Remember, this is a product, which is 11. So first of all, differentiate. I'm gonna get 2x plus 左微分右 plus 左右微分 minus 2y y dash is equal to derivative of 11, which is 0. Okay, now I'm gonna plug in 3, 1 to find the slope of the tangent line at the given point. So 3, 1, x is 3, y is 1, x is 3, y is 1. So y dash plus 7 is equal to 0. So y dash is equal to -7, okay? So you know that the point of the tangent line, point of tangency and the slope. So the equation of the tangent line is y minus y value is equal to slope x minus x value, which is y is equal to -7x plus 22. Okay, that's the tangent line. Normal line, well, if you have a tangent line, looks like this. Normal line is perpendicular to that. So both of them go through the same point, 3, 1, but the slope is different, and the expression is going to be just change this one into the negative reciprocal. It's going to be 1/7, and after that, you're going to have the same. I mean, you're going to get the same thing. Yeah, my answer is written here. Okay. Okay, this is basically same question with slightly different expression, but I'm not going to explain here. Okay, so I'm going to skip this. This one is also the same questions, but we have some sign function, so I'm going to explain this one. So the idea is same thing as number 13, just differentiate, then plug in. So you have y is equal to 6 times sine of pi x plus y. Okay, we need to find the slope of the tangent line first. So let's differentiate both sides to find dy dx. So dy dx is equal to 6 times derivative of cosine, derivative of sine. Derivative of sine is cosine u times the derivative of the inside, which will be pi plus y dash. Okay. You can expand this one and solve for y dash, but we don't need to simplify the expression for y dash. All we need is what is y dash at x is 1, y is 0. So at 1, 0, you're gonna get y dash is equal to 6 cosine of pi times 1 plus 0 times pi plus y dash. Now, cosine of pi is -1. Cosine pi is -1. So it's going to be -6 parentheses pi plus y dash is equal to y dash. Okay, so now it's easy to solve for y dash. So let's expand this one and solve for y dash. So y dash is equal to -6 pi minus 6y dash. So combine like terms, 7y dash is equal to -6 pi. So y dash is -6 pi over 7. Okay, so that's the slope of the tangent line at 1, 0. Okay, so you have a point, you have a given point of tangency, and you got the slope of the tangent line. So you can find the equation of the tangent line. So tangent line is y minus y value is equal to a slope at that point, x minus x value. Okay. For the normal line, at the same point, you just take a negative reciprocal. So it's going to be 6 pi and 7 switched. It's going to be the same thing like this. Okay. Okay. Very looks ugly. The value we have to plug in is kind of ugly, but let's do this one. Number 16. So number 16 is y to the power of 4th minus y square minus x square is, yeah, it's kind of have a lots of symmetric property, but problem is the same. So you need to find the slope of the curve. Same thing as y dash at the given point. Okay, slope of the curve is same thing as y dash at the point. So differentiate once again. It's going to be 4y cubed times y dash is equal to 2y times y dash minus 2x. Okay, it seems like you need to find the slope. We need to find the y dash for the 2 different points. let's simplify this expression for y dash. Okay, because I had to evaluate at 2 different times. Maybe solving for y dash might be easier. Okay, because I don't want to solve twice. Okay. まあ2回同じような計算やらされそうなので、とりあえず y' について解いてから代入した方が計算量少ないかなと判断し、今回は、y' をね、y' についてね、真面目に解くという感じですね。Let's divide top and bottom by negative 2. Okay, so negative 2, so it's going to be y minus 2y cubed. Okay, so this is a better expression. It's easier to substitute. Okay, now first question. At x is square root of 3 over 4 and y is negative 1 over 2, y dash is equal to, have to be careful because this is complicated. So negative 1 over 2 minus 2 times negative 1 over 2 cube, which is square root of 3 over 4 over negative 1/2, negative, it's going to be positive, positive 1/4. Multiply top and bottom by 4. Okay, multiply top and bottom by 4 to simplify the mixed number. You want to get square root of 3 over negative 2 plus 1, which is negative square root of 3. Okay, so that's a slope at the y dash, a slope at this point. For the second part, you just do the same thing with just input the different values and calculate carefully. Okay, so I'm not going to explain that, but you just plug into here. Okay. Okay, number 17. Now you have a different curve, and you need to find the equation of tangent and normal at 315. Okay. So again, it's the same question again. Yeah, basically same thing. So differentiate, plug in 3 and 15 to find y dash, and you find the equation of the tangent line. So let's do. So 6y squared times 6 minus x is equal to 25x cubed. Now let's differentiate. So it's a product. So it's going to be 左微分, which is 2y times y dash times 右 plus 左右微分, which is negative 1 is equal to 75x squared. Now you can solve for y dash, maybe, but maybe you don't really need to. You just kind of plug in right now. So at this point, let's plug in. Okay, so at 315, so you're gonna be plugging 315. So y is 15, so it's gonna be 30 times y dash times 6 minus 3, which is 3, plus minus y square. Y square is 15 square. So it's going to be minus 15 square is equal to 75 times 3 square. Okay, so this is 90 y dash minus 15 square is equal to 75 times 9. You can use a calculator, but you notice that all of them is multiple of 5 or maybe multiple of 15s. So you can factor out 15. So that makes computation much easier. So you factor out 15, then divide both sides of the equation by 15. Now it looks much nicer. 6y dash minus 15 is equal to 45. So 6y dash is equal to 60 and y dash is equal to 10. Okay, so that's the slope of the curve at the given point, and it's the slope of the tangent line as well. Now, once you got the point of tangency and the slope of the tangent line, you got the solution. Okay, so the solution is actually here. So y minus y value, slope x minus x value. Okay, which can be reduced to y is equal to 10x minus 30 plus 15. So it's going to be 10x minus 15. For the normal curve, only this part is changed to negative 1 over 10, and everything else is the same. Okay, for David's curve, It's like you have to evaluate at 4 different points. But notice that this expression is symmetric with respect to y-axis, and it's symmetric with respect to x-axis. So once you find the slope at one point, you can just flip signs to get the slope at the other 3 points. So it looks like a 4 computations, but once you found one, basically you are done with all others. Okay, so use the symmetry. Okay, number 18. Y fourth minus 4y squared is equal to x to the fourth minus 9x squared. Now differentiate both sides of the expression. You want to get 4y cubed times y dash minus 8y times y dash is equal to 4x cubed minus 18x. Okay, now you want to find y dash. You want to solve for y dash. This is kind of simple expression, so maybe we can just solve for y dash this time. So it's 4y cubed minus 8y y dash is equal to 4x cubed minus 18x. Divide both sides by this to solve for y dash. You can simplify top and bottom by 2 to get 2x cubed minus 9x and 2y cubed minus 4y. Okay, once you find this, just plug in for just one of them. Let's find it at 3, 2. At 3, 2, that's going to be the easiest one. Y dash going to be, so 3, 2, it's going to be 3, 3, 3, 3, 3, 3, 27, 54 minus 27 over plug in 2. It's going to be 16 minus 8, which is 27 over 8. Okay. So the slope at this point is 27 over 8. Now, if you notice the symmetry with respect to x-axis, then slope at this point must be just you change the sign, you get negative 27 over 8. And the slope at this point is also negative 27 over 8. And this point gonna be, you flip, you're gonna get back to 27 over 8. However, even if you didn't notice this, you just need to plug in like negative 3, 2 here, 3, 2 here, negative 3, negative 2 here, and so on. So even if you didn't notice it, it doesn't take much time for you to complete all 4 problems. Okay, 2 more questions. Okay, number 19. So number 19, you have some kind of simple expression, y squared is equal to x cubed. Okay, now you need to find the constant b so that y is equal to negative 1/3 x plus b meet this graph orthogonally. So what is meet orthogonally means? So meet orthogonally means actually it is perpendicular to the tangent line. Okay, so this one is actually the normal curve at some point of the curve. Okay, we don't know what this point is yet, but we know that the normal curve have a slope of negative 1/3. That means the tangent line has a slope of 3x, okay, plus something, okay? So slope at this point is 3, okay? So we want to find a point that makes the slope of the curve or slope of the tangent line is equal to 3. Okay, so we want to find a point. We want to find a point such that the slope is, or like y dash is equal to 3. Okay. So with this in the object, so let's differentiate this one. It's gonna be 2y y dash is equal to 3x squared. Okay. Now we know that the slope when y dash is equal to 3, it becomes 6y is equal to 3x squared, or 2y is equal to x squared. Okay, so that's all we know so far. Can we solve for this? Not by itself. However, x and y are related by this expression as well. Okay, so this point, let's say this point is let's give some name for this point. So let's say this point is x naught, y naught. Then that point must satisfy this equation. So x naught square must equal to 2y naught. But at the same time, this point is on this curve. So that point must satisfy this equation as well. So this is, you got the system of two equations, two unknowns, and you just need to solve for this. Okay, so let's do the substitution. Rewrite this into y naught is equal to 1/2 x naught squared. Plugging into here to eliminate one variable, x naught cube is equal to 1/2 x naught squared. Okay, so it's going to be x naught cube is equal to 1/4 x naught to the power 4th, which is a quartic equation, but multiply both sides by 4 to remove the fraction. And let's factor on factor like this. Okay, there are two possible solutions to this equation. One of them is x naught is equal to 0 from here. Another answer is x naught is equal to 4. Now, which one looks a good one? Let's see. When x naught is 0, then from this system of equation, y naught must be 0. But that means the slope cannot become 3 because, oh, 何した?何をしたんだろう。I'm sorry. I'm gonna pause. Okay. So if x naught is 0, then from one of these two equations, you got y naught is equal to 0. However, as you see from the graph, 0, 0 doesn't give the slope of 3. And in fact, if y is 0 and x is 0, y dash cannot become 3. So that does not satisfy our requirement. Okay, when x naught is equal to 4, y naught is actually equal to 8. And in that case, that satisfies this equation, and that's gonna be the point on the curve. Okay, so now we know that this point is 4, 8. Okay, now you should be able to find the slope, y-intercept of this equation, because this line goes through 4, 8. Okay, so since 4, 8 on the line, also gonna line y is equal to 1/3 negative 1/3 x plus b, 8 is equal to negative 4/3 plus b, so b must be 28/3. Okay, so this is kind of one of the harder question in this section. Okay, last one. The last one is number 20. I should finish it in less than 4 minutes. This is related to next section's question, which is about the inverse trig functions. Okay, so we are interested to find the derivative of the inverse sine function. The inverse sine function means, this means same thing as sine of y is equal to x. Okay, so although you don't know how to find the derivative of this one yet, but you know how to find the derivative of this one. So let's differentiate both sides of this expression with respect to x. Okay, so let's differentiate both sides. Okay, now the first part is what is derivative of x with respect to x? So it's basically asking about this part, and of course it is equal to 1. The second part is also easy. What is this side? What is this side? This is same thing as cosine y times y dash. And in this picture, it said, well, just y dash is just written in dy dx. Okay, so the first two part is asking about right-hand side and left-hand side. Now, to find y dash, what dy dx, that's equal to 1 over cosine y. Okay, so that's part 3 here. Now, this is the hard part. Well, how do we rewrite this expression? Okay, so remember what y is. For first of all, y was inverse sine of x. So plug in this one into here, y dash is equal to 1 over cosine of inverse sine of x. Okay, so we need to know what this really is. Okay, and we want that to be equal to this expression. Now, how do we find this? So consider about this expression in right triangle. So sine y is equal to x means when you have a right triangle with the angle is y, then and the hypotenuse is 1, then sine value is actually this part. So this is x. Okay, so this tells you that the sine y is equal to x. Now from this picture, you can find what cosine y is, because you know this part is, by using a Pythagorean theorem, must equal to 1 minus x squared. So you know cosine y must be square root of 1 minus x squared. So 1 over cosine of y must be 1 over square root of 1 minus x squared. And that's going to be the formula for the derivative of the inverse sine function. That's going to be covered in section 3.9. Okay, but for this problem, this is just asking which must be true. So we want that to be equal to this. So this question is just asking for what this should be equal to. Okay, and that's actually this is equal to, should be equal to this. That's what the C is. Okay, so that's complete explanation for this section. And the next time I'm going to cover section 3.8. Okay, so thank you for your participation and see you next time.